Here we are going to present a series of videos for the mechanical branch students who are going to appear for various technical examinations like GATE, BARC and other competitive examinations. In this part, we are going to solve important questions and various important concepts covered in the previous questions of the GATE. So as a part of which, here I am going to present the only important questions and concepts that are covered in GATE 2019 afternoon section. As we know, GATE is held in 2 sessions. We are going to present 2 videos for each session, and we are not going to cover every problem. Those problems which involve a direct substitution of the formulas are left, and which involve a little bit thinking over application of the existing formulas are only discussed here. Okay, we will consolidate all the important formulas that are asked in all previous questions of the GATE later in one video. Okay, let us now first explore the important questions that are asked in GATE 2019 set 2. Okay, here the question asked is an elastic bar is subjected to an uniaxial tensile stress of 100 megapascals. Okay, it is an uniaxial tensile stress subjected to 100 megapascals, and the stress condition is plane stress condition, and the given data is Young's modulus E 200 MPa and the Poisson's ratio as 0.3. Now we are asked to find the principal strains of that particular bar. Okay, as we know, plane stress is a condition in which the stress exists only in the plane condition. Okay, the plane which is normal to that plane, there the stress doesn't exist. So if the stress is in the xy plane, if the plane stress is in the xy plane, then it is very obvious that sigma x normal stress in the x direction and normal stress in the y direction, and the shear stress which is on the xy plane, these values only exist. Any other stress component which involves a variable z is 0, like sigma z and tau xz, tau yz, those are 0. The same thing holds good for the principal strain condition, plane strain condition also. Okay, here we are given plane stress condition, so that does mean sigma x and sigma y exist here and sigma z is 0. Okay, we are asked to find the principal strains, right? So first let us find the principal strain along the x direction. The formula for this is the principal strain along x direction is the normal stress along x direction by Young's modulus minus Poisson's ratio into sum of principal stresses along other 2 directions by Young's modulus. Since the z component is 0 here because the plane stress is mentioned, so sigma z turns out to be 0. So if we substitute the values, the sigma x is 100 MPa by Young's modulus is given as 200 minus mu is 0.3 and sigma z is 0. So the formula turns out to be mu sigma y by E, but the sigma y value is also 0. Y means here it is mentioned as the stress condition is plane stress, and the stress component which is acting on the bar is uniaxial stress. So that does mean stress is only along the axial direction of the bar. So sigma y also 0 here. So sigma y is also 0 here. So this entire component turns out to be 0. So the sigma x value is 1 by 2 which is 0.5. Similarly, the principal strain condition along y formula is principal stress along that particular direction sigma y by E minus mu, same sigma x plus sigma z, other 2 components of the stress by E. Sigma z is E. Here sigma y, as we already discussed, stress component along y direction stands 0, so this entire value turns to be 0. So the final value is minus mu sigma x by E. Mu is 0.3, sigma x is 100 by 200, so it is minus 0.15. So these two are the principal strain values for this particular prismatic bar which is being acted upon by the uniaxial tensile stress. Okay. Now let us see the another problem. The state of a point is represented by a Morse circle where the radius of the Morse circle is 100 megapascal and the center of the Morse circle is at 200 megapascal along the normal axis. Okay, let us draw the diagram. As we all know, this is the Morse circle coordinates. A general Morse circle is supposed to be at somewhere here. This is normal axis sigma line. This is normal stress axis line. This is shear stress axis line. Okay, this value stands out to be sigma x. This extreme value, this minimum stress value is sigma y. This is the center. Okay, so the center is at 200 megapascals here and the radius is given as 100 megapascals, and here a point is taken whose normal stress component is 260 MPa. So till here it is 200, so somewhere here 260. If we draw a point, the point which touches the circumference of the Morse circle, here is the point which is mentioned in the problem. The state of this point is where the normal stress is 260 MPa and we need to find the shear stress at this point. Okay, the radius is known as 100 MPa. Okay, now we need to find the tau xy. As we know, a well-known formula which establishes a relationship between normal stress and shear stress and the radial component of a Morse circle, which is maximum shear stress tau square max is equals to sigma x minus sigma y by 2 whole square plus tau xy square. Okay, here we know the sigma x value which is 260, sigma y value yet to be known, and tau xy is what we need to find, and tau max is nothing but the maximum shear stress component. The maximum value for any circle is the height of the radius, so the radius is the maximum shear stress. As the radius is given as 100 MPa, the maximum shear stress value is 100 square. Okay, plus tau xy square is what we need to find. So sigma x is known, sigma y need to be known. Sigma y can be known from the given data. We have the value of the center is at 200 megapascals. So center value is 200, comma 0 coordinates. The center value is sigma x plus sigma y by 2 comma 0. This is the coordinate of the center of the Morse circle. So 200 equals to this. If we equate that, sigma x plus sigma y equals to 400, where sigma y equals to 400 minus sigma x is 260 MPa, so it is 140 MPa sigma y. So if we substitute here sigma x 260 minus sigma y 140 by 2 whole square, then tau xy square is 260 minus 140 is 120, 120 by 2 is 60, 60 square. So tau xy square is 100 square minus 60 square, which is a plus b into a minus b. It is 160 into 40, so 6400. So tau xy is root over 80. Okay.